So managing vector data. And what is vector data, Tom? And what's the opposite, or not the opposite? What's vector data's
like
sibling?
Like point data, and vector data is like a bunch of points.
Yeah,
or
bunch
like
of
lines.
Points and lines.
Raster data is like squares.
Right,
like
pixels.
You set a value to a square.
Grid, right. Great. So managing vector data, and we're gonna spend the next several kind of chapters talking about vector data, talking about all the cool things we can do with vector data. But first, we'll introduce vector data again, right? You've got XY pairs called vertex or vertices. And so every XY point could be lat long, it could be state plane, what have you, as a coordinate. And then we also might have some topology. Topology just means how things are linked or connected in a network. So point, line, polygon, and the data are stored in the shapefile, that .shp file. That's where that has all this coordinate data in it. So we have vertices, and then we have nodes, and nodes are the endpoints. And we'll talk about editing this probably next week, how you can edit these lines and create points and all that stuff, like if you're going to digitize something. There's also something called multi-part, which is you've got one component that has multiple pieces to it. That's a little funky. So you can think of like Hawaii. Hawaii is one state, and so it has one kind of like entry in the table, the attribute table, but it has lots of polygons representing each island in it. So that could be a multi-part. It's a little complicated. I don't think we're going to get into multi-parts, but just want you to know what that is. So we've talked about the attribute table. We've even looked at the attribute table. This is an attribute table relative to the states of the US. And so we've got our shapefile, right, these polygons, and then this table, which is the .dbf file, has all the information we might want to link to these shapes. So the first column we'll have is object ID, and it's just going to be 1, 2, 3, all the way down to 50 in this case, right? Just a unique identifier. We get the type of shape we have, we get the name, there's a code associated with it, all these things that we could link to that. So what we're looking at is another name for it is called a feature class. Shapefile and feature class are the same thing, and we kind of use them interchangeably. So in this case, it's a collection of similar features stored together like a data set. It includes the spatial data as well as the database files. Yeah, I don't know what to say about spaghetti models. We're not going to really cover spaghetti models. I guess the idea of a spaghetti model is here's a bunch of shape files, and each one is unique. So I can click on Washington, and it has its own boundary. I can click on Oregon, it has its own boundary. Idaho has its own boundary. And this information is kind of redundant, right? Because you have a boundary for Idaho, it's the same boundary that partially that Oregon has, but you've got redundant data for each of these polygons. So it's easy that you could like copy very easily Oregon and put it into a new shapefile, something like that, because it's its own unique feature. But we can also have what's called topological models, and we talked about topology. This just means connections and networks. And this could tell you, for example, where you have overlapping connection. This is a little more complicated model and gets into networks. And if we do have time towards the end of the semester, we'll talk about networks, where you can represent things not only as just coordinates, but also what's connected to what, and how do you get from point A to point B via a road network or something like that. So it's more of a relational thing. Okay, so GIS data are complicated, and that's kind of the main point of this lecture, and just how to deal with that complexity. So we can have really big files, right? If we were to have a point file, one of the files we'll be dealing with in the kind of homework assignment we'll have in a couple weeks on this is all of the dwellings, occupied dwellings in Mesa County. And there's tens of thousands of them, right? So that's going to be a pretty big shapefile. There's a lot of points, a lot of data associated with that. GIS data come from many different sources, so we can download data from the county, we can download data from the state, from the federal government. Maybe we're going to make our own data in-house, and they're all going to have different coordinate systems and kind of different ages and stuff like that. Sometimes they're going to be on a file server, an online source, or locally. They're not always going to have the latest file conventions. Maybe we don't have a projection file. There's just a lot of, it's kind of a mess. And we'll be dealing with that mess as we kind of do these projects and these tutorials together. So there's a lot of ways we can organize our data to keep from running into pitfalls. Folders are really important. Try to avoid using desktop or document folders. Obviously, this is, we're using this for our tutorials and stuff like that. You can use your documents folder, but when you're doing real projects, your company is going to have the GIS folder, right? And there's going to be different data associated with that. So they'll have their own file system. As you go and do GIS analysis, we'll learn that you're going to be doing kind of step 1, and then you'll do step 2, and then step 3, and you're going to be kind of making changes to these files as you process them over time. And so GIS will often make a standard default name for you. So you're doing raster calculator, and you end up with raster calc 1, 2, 3. It's going to be really easy to get lost and forget what's what. And so using descriptive names is really important. So that's one essentially we'll use. Another tip is spaces, especially for folder names. That will run into trouble with GIS. And so when we're making a new folder, avoid spaces, use underscores or dashes, something like that. So we want to avoid spaces because ArcGIS does not like spaces. And some things will not work, and you've got errors, and you won't know what's happening. The other important thing is extensions. So we've taken a look at shapefiles in a folder itself, and we've seen that for example, roads shapefile, right? When we're doing the coordinates, there are probably 6 different files that have roads.something, right? .shp, .dbf, .prj, etc. So by default, unfortunately, Windows hides extensions. You can change this under File Explorer options and making sure that this box is unchecked so that you can see those extensions. So when you open up the folder and you want to copy everything, you can make sure you're getting all the important extensions that you need for a particular shapefile. Talk about this one. So you guys are familiar with zipping, it seems like. We've downloaded zip files and unzipped them. Maybe I haven't talked about it explicitly, but zipping is an important tool. It's an archive. It creates a folder that's like one file, essentially. Within that folder, it contains multiple files. Often when we're sharing GIS data, because it's so many files, it's clunky to upload 12 different files on an email or to share it some other way. So we zip them. ArcGIS, you have to unzip them before you can use them. And so if I say, okay, go ahead and go on Canvas and download this zip file for this in-class lab, you download the zip file, you have to extract it. And with Windows 10, that comes automatically. You just right-click, extract, it makes a folder, all the files are there. It's unzipped. And then from there, you can use the files. So that might be not new for you. I just assume people know what zipped files are for my classes, but I've run into cases where it's been a new thing. So I just want to make sure that's covered. Once it's unzipped, it's just a normal folder and you can access the data inside. I think Windows can make it seem like you don't have to unzip things because you can click on a zip file on Windows, open it up, look at the pictures or whatever. That doesn't work for ArcGIS. So we'll be importing data and exporting data. And importing is pretty basic. You just bring it into a map. But we'll be dealing with something called a geodatabase. And we've looked at that. It's a folder. It kind of looks like it's a file extension, right? But it's also a folder. It's kind of like a zip file, to be honest. But we can't really look inside with Windows Explorer. And with geodatabases, you can create one and import data into that geodatabase. And that will take it from a standalone shapefile and put it into the geodatabase. And then you can also export things. And so if you have, when you're making a map and creating files and changing files, by default, it's stored in the maps geodatabase. This is a geodatabase that's created when you create the new project. And so when you create new data, it's going to go into that geodatabase, but you won't be able to necessarily share that data with someone else because it's sitting inside your geodatabase and it's in a weird format. And so one thing we'll do is export data. And by exporting data, it's just a tool that will create a shapefile or something like that. That's a standalone thing that you can share with someone else. So that creates a new file. When you compile data to make like a data package, you'll probably do a metadata exercise. Metadata, who knows what metadata is? You heard that term elsewhere?
Just only in GIS.
Okay.
Like in the program.
Yeah. So do you have an understanding what it is, Tom?
I don't know, it's kind of like it's like information about that specific like folder or something. I don't know.
Yeah, it's just like the data that tells you where this came from. So I have a shapefile of the all the trees in Grand Junction. So someone went out and surveyed all the trees. Well, where did this data come from? Who collected it? What year did they collect it? What equipment were they using to collect it? What's the spatial accuracy of it? You know, so it's all the kind of behind the scenes data that might be important. Do we care about, you know, the spatial precision of a tree survey? Not really, but maybe if it's topographical data that I'm going to use for a design, then I want to know really where did this come from? Did someone go out and survey it? What equipment are they using? Did it come from LiDAR, et cetera? So it's the data that really documents where everything came from, the kind of provenance of the data, and usually attaches the owner of the data who created the data set, what's their contact information, you know, stuff like that. So what else we could store in the metadata is the source scale, right? So this was digitized at 1 to 50,000, and that gives you an idea of the resolution, the appropriate resolution of that. So a few more kind of random items. These are just kind of a compilation of file stuff. When we can bring in a table. So a great thing, maybe we'll do this together. A great thing you can do in GIS is to bring in a table, like an Excel table that has coordinates. And then you can use a tool in GIS to map those. And so you say, okay, here's my X field, here's my Y field, here's the coordinate system associated with that. And then that will allow ArcGIS to create a shapefile of those points. There's a geocoding tool, which will actually link an address. So if you have a table of addresses, street address, city, zip code, there's actually a service that will attach an XY coordinate with that. So I can give you a table of all the addresses that have water service lines that were installed between 1965 and 1983 that could have lead. I'm making those dates up, but that's like an approximate range of when lead was introduced or before 1983 or something like that. And then I've got that list, it's in an Excel file, I can throw it in here, and then it'll, with this geocoding service, it'll code it and then give me a map of where my homes are. So I can kind of look at the spatial distribution of those. We'll take some time. So I guess we'll probably need this tutorial, so I'll just introduce the concepts. We can do lots of different things with spatial data. So we can clip things. We can take, say, a square and a circle, and then clip it so that we only have the information that's within this circle. We can also erase data, so this would create a hole based on that circle file. We can merge different data sets together. These are two shapefiles, and I create one shapefile that's merged them. And then now they share the same kind of color scheme and everything. This would be like two quadrangles of a geologic map, two adjacent quadrangles. Okay. Generalizing. This generalizing is a tool that will allow you to take a really complicated polygon and make it a less complicated one that you can zoom out for us. If I have country data that's really high resolution and I want to make it less refined, so I can have a bigger map scale, then I could use this tool. You would end up with a smaller file size for that. Dissolving is another nice tool that we have where you can take different shapes, different boundaries, and based on certain rules, a certain attribute field to say, I wanted to, all these are the same number for region or something like that. I could merge all those based on that shared ID number. And so it kind of simplifies a file like that. So here's a little bit more about metadata, and there's actually a file. It's an XML file that you can store this metadata in. And the idea is that this data travels with the data, right? It's part of the shapefile, that list of files. And here's just an example of the metadata for the US. It's got tags, so you can search it, right? A summary description of what it actually is, credits. So this is kind of like minimum stuff, but you also have like contact information and maybe methods and stuff like that. Appropriate scale range, that's a really important one. And a bounding box that tells you where this data exists in space. Here are all the different kinds of data we have at kind of a high level. Talked a lot about shapefiles. Coverages are old. Hopefully we won't encounter them. Geodatabases are really important. They contain a lot of different shapefiles or rasters. Database connections are basically just web addresses. A layer file. Did you guys deal with layers yet in these tutorials? Okay. Layers are basically when you load a shapefile into your map, you can change the symbology, right? You can make it this pink, or you can make this shade or whatever, this line thickness. And that's all saved in that map in the APRX file. It's not saved in the shapefile. And so if you want that to translate, you want to send someone your beautiful map, well, the shapefile, but you want to display it in a certain way to show those categories or whatever, you have to actually create a layer file. And we'll get a chance to do this, but it references the feature class or the shapefile and stores information about how it should be displayed. So this is your symbology file, and unfortunately it has to be a separate file. This is one of my beefs that they should have updated this, right? Like, why not just, for your shapefile, save a file automatically that stores all that symbology. So you have to do it separately, and you can export it as a layer file. And that layer file will have to travel with the shapefile and reference it. So you can have tables. These can exist separately. Bring a table in, connect it to a shapefile. by basically doing a database query and counting the rows. We'll deal with tins later. These are, it's vector data, right? Because it's coordinates and lines, but it represents a surface elevation. And we can also deal with CAD drawings in ArcGIS. I don't think we'll have time to do that, but that's something that they can go back and forth between CAD and ArcGIS. Let's look at the shapefiles a little more specifically. This is kind of your standard series of files. This is what it looks like when you import it in ArcGIS. You just see this one file, but really in Windows Explorer, you see all these things, right? So if we're going to move this shapefile and send it to someone, we need to zip all these up together. Everything that has this one name to the left of the period. Into that. All right, and then for path names, we kind of ran into this error, I think, for the first tutorial when, Felicia, you created, I can't remember exactly what happened, but you created a new map, and then it didn't reference where the data was because it kind of lost, the path broke, basically, right? And so there's this idea of an absolute path, where if you have everything in a folder, and in that folder, within that folder, you have the map, you have all your shapefiles, everything is kind of below in subdirectories, right? And that's great and everything's working, but if you have if your map is stored as an absolute path, then you move that folder somewhere else, all those links are going to be broken because everything above, say this is your folder, or say Oregon's our folder. If we moved Oregon into something else, like a thumb drive or something like that, it wouldn't recognize it because all of a sudden this would be different, this would be different. Everything upstream would be different. Relative path names start at the project file and are relative to that. And so it doesn't matter what's happening up here. If this is our project folder and our maps and everything's referenced downstream, then we're good and we can move this folder wherever we want. It doesn't matter what's happening up. So that's a relative path. I think by default, everything is stored in relative. Yeah, so by default, Pro is ArcGIS Pro. It stores relative paths for data on the local hard drive, absolute paths for data on the network file server, so that network file should never change. And that usually should work well. In the previous version of ArcMap, that wasn't the case. It was always absolute paths. You had to do this by default. If you run into situations where you see this exclamation point, that means a path has been broken. Or there's some bad like referencing, you might have spaces in folder names or something like that. And so usually you have to right click and then you can go repair that broken link. Okay. So that's some boring IT stuff. And what's the best way to learn that? Well, it's just kind of working with it and running into those problems and fixing them as they go.